Okay, good morning everybody. Today we're going to take a look at a new conic section called the hyperbola, right here. And my hopes is that we'll be able to get through this as painlessly as possible. The good news is the hyperbola is a lot like the ellipse in how we find the center and how we're going to find some fairly important points. The difficult parts are in understanding how a hyperbola is different. I don't want to proceed with that. The difficulty of recording while online. We'll close that again. And there we go. Okay, so what we're going to do is take a look briefly at some of the questions we'll be looking at. So here we have our exercise number 38, in case you haven't guessed. And let me just highlight sort of here a few things that are different. You can see that we still have our y squared, we still have our x squared, and same thing here. In this one, you'll notice the y squared comes first. Here it's second. This can be certainly true for hyperbolas, and you shouldn't let that sort of bother you in any way, shape, or form. Now, the big part. The big part that most students kind of go, hey, this is really new, is the minus sign. We haven't seen a minus sign between squared terms before like that. Certainly not when we're graphing one. Here's another one here. Now, I don't want you to be alarmed, but you can kind of tell this one's different. It has a plus sign, but the negative sign is right there. So these all qualify as hyperbolas, and we need to understand how to cope with them. Okay, so what I'm going to do here is we're going to go back to here, and I'm going to hopefully give you a taste of what to expect in terms of graphing a hyperbola. So typically, hyperbolas have the standard equation of, we're going to have x minus h squared over a squared minus y minus k squared over b squared equaling 1. Or, now this is a big or, okay? We might also have, now there's two ways to write this. I'm going to show you the way that I think is easiest to understand first. We're going to have y minus k squared over a squared minus x minus h squared over b squared, and that also equals 1. Do you notice how, and this is sort of a big picture idea, we have this term coming first? That's going to be a really important idea. The other, of course, option is that the x squared instead comes first, not second. Those are going to be some important ideas when we need them. Okay. Now, the good news is here. Actually, before I move on, let me highlight just a couple more points. Just like the ellipse, so in ways that they're similar, things you already know. HK is the center, although the center in this particular shape, well, it's not debatable, but it's certainly there. HK is the center. A, or more rather the square root of A, are points of interest. Now in this case, I'm going to put in brackets, these are intercepts. In fact, let me just back up and reword this. Root A, or more appropriately, plus and minus the root of a. Our intercepts, what I'll call real points. Okay. Plus and minus the root of b. These are the ones that I'm going to call points of interest. Now, that means that we're going to have to graph them, okay, to get our hyperbola. We're going to have to graph both sets. A, plus and minus the root of a over here. These ones are real. We're actually going to plot them. These ones we're going to plot, but they're not part of the graph. They're not part of the hyperbola. But in any event, hopefully you'll kind of see what I'm getting at when we get to an example. Okay? Okay, let's go and take a look at our first hyperbola. This funny looking shape here, both parts of it, is what we call a hyperbola. Now, specifically, this is the hyperbola of y squared minus x squared equals 1. Let me show you why. Now, let's look at this point in particular. This point has the value of 0 and 1. And so you can see that if I put 0 in for x, y is going to equal plus and minus 1. And that's why we have a second point down here at 0, negative 1. Now what's true is that we can begin working on other points as well. Okay, so let me just demonstrate. Let's substitute instead. 2 squared's not nice. 4 squared. Let's. Oh, sorry. Well, let's just put in another point. Let's take y squared minus 2 squared equals 1. So you can kind of see where I'm going with this. Y squared is going to equal 1 plus 2 squared, or 4. So y squared is going to equal 5, and y is equal to plus or minus the square root of 5. And so if you come over here to 2, here we have plus root 5. Sorry. And down here, we have 2 and the negative root of 5. Okay? Now, we could go on, but you can kind of see how this works. Let me erase all of this. I'm going to put those points back in, and I'm going to show you the same equation, just written in a slightly different fashion. X squared over 1, y squared over 1. Same equation, we've just written in the denominator. Now, in this case, a squared equals 1. So a is, equal to plus and minus the root of 1, or plus or minus 1. And those are these two real points right here. Now, this is why they're on the y-axis, because it's under the y. When y equals 1 and x is 0, we have real roots. Okay? Now let's consider what happens if x equaled 1 and y equaled 0. Now y squared over 1 minus x squared over 1 equals 1. If y were to be 0, I'd have 0 minus x squared over 1 equaling 1, which would really mean that x squared equals negative 1. I'll just pause while you think about that a minute, because that would mean that I would have to try and take the square root of a negative number. And of course, we've always taught you that that didn't exist. What doesn't really exist, we imagine it. And so what we do is we put 2 points like this, and we imagine that they're there. The other ones are there because they're real. If I set y equal to 1, 1 squared over 1 equals 1, and x would have to be 0. That's why these 2 points are real. They exist. They're on the graph. These 2 points are imaginary. Now that's a fair bit to take in even in just one lesson. Okay? But let me show you what we do with these points. To get our graph quickly, we find these 4 points and we decide which 2 are real and which 2 are imaginary, and we draw a box consisting of straight lines between all 4 points, like so. Now forgive me, I don't think I can draw a straight enough line quite to show you what I mean, but this is what we're going to do now. I'm going to take a straight line and I'm going to draw it through the diagonals of the box that I have drawn. And hopefully you can see a pattern here. So I get the other one drawn, like so. These lines are the asymptotes of the hyperbola. And so what we do is, we draw the box first, we label these points, we draw the box, second, we graph our asymptotes third, like this, and then we take our pencil and we sketch the hyperbola, like so. Okay? So, let's go back to our notes and write that little procedure down so that we don't forget. To graph a hyperbola, 1. Determine the center. I'm going to show you one that has a different center in a minute. 2. Find plus and minus the root of a. These are the real roots. And plus or minus root b, the imaginary roots. 3. Plot the points from 2. Step 4. Connect the points using a rectangle. It'll usually be a rectangle, it's not always a square. Using a rectangle. And 5, draw the asymptotes like so. And our last step then, I guess I'll squeeze it in at the bottom, sketch the hyperbola. There we go. Okay, so again, we didn't do that one in the last one, but we took you through each of these steps. So let me try and show you one where we'll get to this one. We'll get to an example where we have to do this perhaps a little later. But let me find you something where it looks a little different for that one, okay? Okay, here we go. This is the equation of this hyperbola right here where I'm pointing. Okay? Now, in actuality, you'd likely like it better if it was written like this: x squared over 9 minus y squared over 4 equals 1. Now, to get this form, all I did was I took this equation and I divided each term by 36. Okay? And that gives me the value of 1 out here. And that's something you're used to doing with your ellipses, hopefully by now. Okay? So that's the idea there. That's the first step you want to do, is transform your equation so that it looks like this. Okay? Now, you'll notice right away that if we set y equal to 2, like so, or sorry, y equal to 0, pardon me, y equal to 0, I'm going to end up with x squared over 9 minus 0 equals 1. That means that x squared is going to have to equal 9, and x is going to equal plus or minus the root of 3. And since those are the real roots, the x is first, or the x squared is first, okay, those are the real roots, we plot those like that, there and there. So we've actually almost skipped right into step 2. Now, what we have to do is, from our equation, we have x squared over 9 minus y squared over 4 equals 1. This time we set x equal to 0 to find the imaginary roots. So 0 minus y squared over 4 equals 1. So that means that y squared is supposed to equal negative 4. And so what we do is we take the square root, but we understand that it's imaginary. Okay? Oh, sorry. I don't mean the root of 2. I mean the square root of negative 4. Like so. So what we do is we say, well, that must mean that the roots, the imaginary roots, the roots that don't really exist, are at 2 and negative 2, like that. Now you'll notice that, you see I graphed the function ahead of time, you'll notice that the function never passes through these 2 points. That's why they're imaginary roots. The function doesn't pass through it, and yet 2 and negative 2 sort of satisfy the situation where x squared equals 0. Now my job is to simply draw a rectangle, like so, connecting the 4 dots. I draw the asymptotes, or sketch them, and as the picture gets bigger, this gets even more difficult to do, but if you have a big ruler, I find this part of the course goes much easier. If you can borrow one, or you have a little brother or sister that maybe still has theirs, see if you can borrow it. There's the asymptotes. Since we know where our real points are, we can now sketch the hyperbola. I always put arrows on the ends of your hyperbolas here, folks, because they do go on to infinity in both directions, like so. Now, it's also very important that you always label your points, okay? Like so. And don't hesitate to label, 0, 2, and 0, negative 2 as well. Okay? Now, that's sketching the basic hyperbola. I'm now going to come back to finding the center. Okay? The center of our last hyperbola, let me just flip back here. You'll notice that there's a certain amount of symmetry about 0, 0. Okay? And if I rewrite the equation, x squared over 9 minus y squared over 4 equals 1, you'll see that there's no h and k. Well, h and k really is 0. And what happens is, I'll just give you the box again here real quick, a rectangle, like so. H and k moves the center to wherever you need to go. So if I was going to graph x minus 2 squared over 9 minus y minus 3 squared over 4 equals 1. This point here, 0, 0, would move to 2, 3. That means that this point would move 2 to the right and up 3 as well. This point would move 2 to the right and up 3 here. This point would move 2 to the right and up 3. This point would move 2 to the right and up 3. I draw my new rectangle. I won't draw it in because the diagram's getting quite complicated. Drawing my asymptotes. Now I have my hyperbola. What I'm going to do is this. This video is already long enough, and I know that you'll need some time to get these practiced. I'll flip back to the assignment just to highlight a couple of things here. We'll close that. There we go. What I'm going to get you to do, please, is give your best shot at the first 3 questions here. Number 4, they ask you to find the equation, or they give you the equation of one of the asymptotes. When I get back, we'll take some time to talk about number 4. If you can, give it a try, but I certainly wouldn't be disappointed if you're struggling with that one. Number 6, I think you should probably be able to do as number 7. And then the remainder of the assignment, I believe, oh, there we go, 8 is another hyperbola question. 9 takes us into a circle with an ellipse. 10 is a parabola, so those will be good. And then there's some review. So 1, 2, and 3 for sure. Starting at 6, go to 10, and then finish that assignment. And that will be great for today. Thank you. Good luck. Please don't hesitate to email me if you have questions, and we will see you on Monday.